Okay, guys, let's quickly do justice to the very penultimate question we're given as a take home. So here, a shooter wants to fire a bullet in such a way that its horizontal range is equal to 3 times its maximum height. At what angle should it fire the bullet to achieve this? Now, this question was given to some JAM students in the year 2006. So how do we solve this? A shooter wants something. What does he want? This is what he wants. He wants to shoot a bullet in such a way that its horizontal range is equals to 3 times its maximum height. So this question is very simple. There's no way you'll be able to understand, what we're about to solve if you've not gone through the previous lessons. So why? Because you're going to be needing the formula for max height and horizontal range. So quickly, let's quickly write that down. So what's the formula for max height? So max height, for maximum height attained, the formula is u squared, initial q squared, that's sine squared theta over 2 gravity. Don't forget we derived the formula from v squared equal to u squared plus 2as 0 squared u sine, that's along y-axis all through. So u is u sine theta raised by 2 u squared sine squared theta. Gravity negative minus 2gh. 2gh crosses over u squared sine squared theta divided by 2 gravity. And we end up with this. So that's the formula for max height. Then the formula for range, horizontal range, is u squared sine 2 theta over gravity. So these are the two things you're going to be using. Now, this question, JAM 2006 question, we want us to solve for the angle at which a shooter will shoot to achieve this. And what does the shooter want to achieve? The shooter wants a situation whereby the horizontal range is going to be 3 times the max height. It means this range will be 3 times the h max. That's what the shooter wants. So what's the formula for range? Range is u squared sine 2 theta over gravity. You got to 3 times, what's the max height? Max height is u squared sine squared theta over 2 gravity. Now, this is very simple. Now, before we carry on, it's very important for you to have the basic knowledge of trig identities. I said it in the previous lesson. If you don't understand trigonometry, to a large extent, you find it very hard to understand what we're doing or what we're about to even do right now. So we have gravity. We have gravity on this other side. So gravity takes out gravity. Initial speed squared takes out initial speed squared. So what do we do next? The next thing we do is sine 2 theta is equals to, what do we have? We have a 3 right here times sine squared theta over just 2. So what next? You can bring these angles together. Sine squared theta can come over to meet sine theta, or whatever we want to do it. You can decide to cross multiply like this. Let's do that first. So what do we have? We have a 2 sine 2 theta equals to 3 sine squared theta. So what are we going to do next? The next thing we're going to do is we can send this here. We send this to this side. So 3 takes out 3. Then sine 2 theta crosses. Sine 2 theta, sine 2 theta. So this takes out this. So what do we have left? We have 2 over 3 equals to sine squared theta over sine 2 theta. So we're very close. We've almost gotten what we want. Don't forget, we are asked to get the angle at which the shooter will shoot to achieve what we have right on the board. What angle will it shoot? The shooter wants a situation whereby the range will be 3 times the maximum height. So let's try to see the angle at which the shooter will shoot. This 2 over 3 right here. 2 over 3 got a sine square theta over sine 2 theta. So sine squared over sine 2 theta. So the knowledge of trig identity is very important. Don't forget that sine A plus or minus B, you know what it is? So sine A plus B, we're going to be working on this soon. Sine A plus B will give us sine A cos B plus cos A sine B. Very important. One of the major formulas. So if you talk about sine 2 theta, so what's sine 2 theta then? Sine 2 theta is sine theta plus theta. Theta plus theta will give us 2 theta. So sine theta plus sine theta will give us sine theta cos theta, that's sine A and B. This A and B here, just like what we have. sine theta cos theta, then plus cos theta sine theta. So what do we have? They're both the same. So that means sine 2 theta will give us 2 sine theta cos theta. When we are deriving the formula for range, we derived this very formula. I'd love you to go back and see for yourself. Probably if you've not seen those expositions, go ahead and see them for you to get mass understanding of what we're doing. So what we have, sine 2 theta is 2 sine theta cos theta. That's what we have. Very close to getting the angle at which the shooter will shoot. To achieve an horizontal range, a horizontal range of angle pattern that is going to be thrice the mass height. So what do we do next? So 2 over 3 sine square theta, we know what it is. Sine theta is sine theta times sine theta. That's normal. Then sine 2 theta is 2 sine theta cos theta. So this takes out this. So what do we have left? We can send this 2 over to this place. That is 2 times 2 over 3 equals to sine theta over cos theta. So what next do we have? Someone's got one word. So the next thing we have is 2 times 2 is 4 over 3 equals to sine theta over cos theta. Well, what are we going to get? Sine theta over cos theta is tan theta. I hope you know that very simple. Sine is opposite over hypotenuse, divided by cos is adjacent over hypotenuse. Opposite over hypotenuse, division becomes this up and down. Hypotenuse over adjacent. You're going to be left with opposite over adjacent, which is tangent. So tan theta. So what are we going to do next? Next, we're going to get the arctan or the tan inverse of 4 over 3. So calculator will help us with this. So what's going to be the tan inverse of 4 over 3? The tan inverse of 4 over 3. What do we have? Let's see what we have right there. So tan inverse of 4 over 3. That's 53.1. So that the shooter must shoot at an angle of 53.13 degrees. Very simple and direct. So that's everything for the very penultimate question. So watch out for the very final question on the take home we're given on projector.